of you, welcome back. This is for part 3 of our webinar series on healthy indoor air quality for our schools. And very excited today to be doing this third webinar. We think this is a really important topic. It's very hot, very topical today. So we're going to spend a full hour today on air purifiers in schools. Certainly lots of interesting information going around and lots of activity and discussion among schools about whether or not we need these. So it's great to dive into this topic today with everybody. So really quick, some housekeeping before we get rolling. Our format today will have this is a big one. So we've got a pretty solid 45-50 minutes of content. This session is being recorded, including all the Q&A at the end. If we have more questions, we'll keep going after 12 o'clock, and if you need to leave, those will all be recorded. You can submit questions through the chat feature at the top of your window there. There's a little bubble, and you can submit questions as we go, if you like. And the recording will all be available to everyone tomorrow. Some legal stuff. The biggest one here, just make sure your schools are all unique, your HVAC systems are all unique. So this is general guidance today, but certainly should not be substituted for advice from either any of our representatives or any other qualified HVAC person that's actually looked and assessed your system. So that's the biggest point there I wanted to make. Presenters today. Many of you have met me, Ian McGilvery. I'll be the host today. I've got very small part of this presentation as well, but the big brains behind this one today are Randy and Patrick. So Randy is our senior corporate technical advisor. He advises our sales team, our customers been with the company for over 30 years. And our second presenter, he'll have a significant portion of this today, is our senior engineer, who's been very involved in our purifier program. Lots of experience evaluating these devices, putting them into client sites, everything in between. So great to bring our engineer to the discussion today. And after that, just really quickly about us for the new folks here. BGE, we are a Western Canadian indoor air quality and filtration company. We're family owned and operated, been around about 53 years. We have an equity business partner, Fort McKay First Nation, so we are partly Indigenous owned as well. For those of you who don't know, Fort McKay is just north of Fort McMurray. 7 branches across Western Canada. We have our headquarters, manufacturing, and our central distribution center in Edmonton, a couple hundred employees, many customers across many sectors, but in particular relevant to today. We work with about 120 different school boards across Western Canada, as well as universities, colleges. So very familiar with the space in your facility. So we're happy to bring all of that to bear today on this discussion. So now speaking out really quickly, just we're excited about this one today in particular. I think our mix of experience and our team brings a really unique perspective to this topic today. So I mentioned we've been in business 53 years, and the core of our company and DNA is around filtration. And if you think about purifiers, they're filtration and filtration equipment. And if you think about a purifier, it's a piece of equipment that we're deploying, and the core technology inside of it is filtration. So this is right in our wheelhouse in terms of our filtration expertise. We do a lot of indoor air quality assessment monitoring, so we can see the results of these when this technology is deployed. So and we do see it. We've deployed these all over Western Canada, and we can measure the efficacy. So we know really well this stuff works, and we can help you measure and determine the efficacy of these things. We also have significant experience in critical environments, we call it. So that's clean rooms and hospital settings, so really, really clean environments. And the reason those are really, really clean is because they use HEPA technology, and we have highly trained people that can deploy that technology, install it, test it, certify. We certify clean rooms, we certify laboratories, pharmaceutical facilities, all that stuff. So we've got a lot of experience in HEPA in particular, so that's very relevant to the purifiers. We're backed as well. There's not only the expertise of our team, but we've got global partners in the space with very deep engineering and R&D teams that back us up. And finally, the practical field experience. We have technicians out every day in facilities and schools included, and so we understand the deployment challenges of these things and how to make this work in the field. So great topic for us today, and that's it. So quickly for our agenda, before I turn it over to Patrick, we're going to go through just recaps, a few IAQ principles from the last couple of webinars. We'll go quickly because I know there's a lot of people that have already seen those and they're available on video. Then we'll kind of get into what is a purifier, what's inside of them, how do they work, so we understand what they're about and how we can apply them. And Patrick is going to lead the charge on those ones, and then we'll flip it over to Randy, who's going to go through some maintenance considerations, and then a really important topic around how to assess, size, and select these purifiers properly, and then we'll go into some challenges, barriers, concerns at the end. So with that, Patrick, over to you, sir, for this first section. You can take control.
Thank you, Ian. Good morning, everybody, or good afternoon for some of you, but I'm happy to be here. There's a forest of misinformation and information on air purifiers, so I'll be going through this quite quickly, so buckle up and I hope you enjoy the ride. So you can see the first section that we're going through is the portable room air purifiers, and there's various topics we're going to be covering, but I want to start with a recap of the last two webinars. So we talked about the IAQ 360 process and program, and that's something we really believe in and follow, starting with assessing, planning, delivering, managing, and then with each of you, you're going to have your own desired outcomes and constraints. So those get factored into that plan, along with what are the options that you have? And we know what the options are. They're ventilation primarily at the top. That's our number one priority in this upside down triangle. Adding filtration onto that. Those two things, if you can do that and get better IAQ, that's your top two objectives. And then the third piece is to supplement with air purifiers, which is today's topic. There's a lot of standards and guidance that we went through in the first two webinars. So we mentioned ASHRAE, of course, a number of times. They are the guiding principle behind everything we follow for indoor air quality, and they have an epidemic task force specifically for some of this COVID stuff of recent years. And we follow the Harvard Healthy Buildings program as well quite closely, and of course all the government and Health Canada guidelines. And one of our goals that we kind of harp on over and over again is 6 air changes per hour. It's really a target that you should all be striving for within your schools and buildings, achieving that flow rate for best IAQ, for best indoor air quality. So in the first two webinars, we covered off the HVAC and filtration system stuff primarily. We talked a lot about the assessment side because we believe in that. You know, it's really important to do that assessment properly to set yourself up for success. And that involves, you know, knowing your outcomes, and then you move on to planning and delivering and managing. You can't just get into delivering and purchasing something without really understanding what you need first. So that's why we really focus on an assessment piece. So we use those same principles and those same procedures, and we'll talk now about portable air cleaners, which is the subject of today's conversation. And I'll walk through what is an air purifier, why use them, how do they work, and when and where to use them. Okay, let's get started. What is a room air purifier? Well, quite simply, a room air purifier is a compact standalone device that removes airborne contaminants in a room. So that's really what they do. And removes can be capturing or destroying them. And the room can be any size room, but bear in mind that when there's openings and doorways in rooms, and that is it one room, or does the adjacent room count as that same room when the air is flowing freely between them? So the room is just a defined space. But let's talk about airborne contaminants now for a bit. Contaminants in the air. So we all know there's lots of them. It's not just COVID. You know, there's all kinds of things, from smoke particles and molds and odors and bacteria and volatile organic compounds, and of course just dust. And dust can be in every size. And they come from all sorts of different places, from the outside environment, from our neighboring buildings and companies that are operating next door to us, from occupants in our space. And that's the primary one we focus on in the schools. I love this graphic. This is a great graphic because on the right-hand side, you can see a human hair. So that's the size of a human hair. So when we talk about airborne contaminants, what we're talking about is invisible stuff. It's really stuff you cannot see at all. but it's the most harmful stuff of all the things that we have out there. You want to be able to capture and control these. And of course, we're talking about COVID a lot these days, but every time we talk about airborne contaminants that are in the exhalation of people, so when people breathe in and out, we're talking about particles that are in water droplets. And you can see on the right-hand picture here how those water droplets, where they're easy to see when they kind of crystallize in the wintertime, but obviously you're not going to see them indoors or on a summer day because they're too small, they're invisible. But those are the ones that are containing the COVID particles and the viruses that we're so concerned about today. And they can settle in, they can hang in the air for 20 minutes to hours. So especially when we're talking COVID here and very small particles, they can hang in the air for an entire day. And as you get 30 students in a class, they start to accumulate in that space. And that's what we're trying to avoid, that problem of accumulation. So I'll show you a quick video that you've seen before, but this is a really good illustration.
We now know that COVID-19 is spread by airborne particles. One of the challenges of providing a hygienic indoor environment is that infectious airborne particles are typically smaller than the eye can see. Here, we help visualize how infectious diseases like COVID-19 can spread from a single contagious individual. A simple cough or sneeze from that infected person can expel thousands of droplets into the air. Shown here is the red particles the virus travels within the airway from the individual and into the air return vent. When premium filters like MERV 13 are used, the majority of those particles are trapped in the filter and not recirculated into the room. As the air passes multiple times through the filter, the number of virus particles drop dramatically each time. Standalone air scrubbers can even have a greater impact on the indoor air hygiene, as the molecular filtration and proximity to occupants can increase the capture rate and reduce the risk of exposure to the other occupants. One of the most effective ways to provide clean air to indoor spaces is to bring in outside air. Rooftop DOAS units bring in fresh, outside air to flush recirculated air from an indoor space. Introducing additional fresh air through DOAS or dedicated outdoor air systems can serve to dilute the infected particles with additional fresh air, which does not contain the infectious particles. Depending on your particular application, one or all of these methods can have a dramatic impact on reducing the spread of infection through the airborne pathways.
So, love that video. It does a really good job of illustrating and showing you visually how small contaminants move into the room. And remember, those are contaminants that are invisible in normal operations, the ones that we're talking about mostly in today's environment. So let's talk about why we use an air purifier. And I think you all have your reasons, you all know your whys, but ultimately it's to protect people, products, processes, and equipment. And people is obviously a huge one in schools. We've got many students and they're in fairly small spaces. So, but remembering that not all HVAC systems and indoor spaces are created equal. That's where we do that assessment of whether an air purifier adds value. Why use them? Well, we use them because of COVID primarily. That's the conversation of the day, and we know it's airborne. We absolutely know it's airborne. But it's not just for COVID. It's for general indoor air quality. And to get that air moving, to get those air changes per hour that we need in our rooms to get that healthy indoor air quality. So it's for harmful small particles of all different kinds. And those you can breathe harmful dust particles that are invisible deep into your lungs, and those are concerns for health. Wildfire smoke, volatile organic compounds, there's all kinds of these. And again, begin with the end in mind. What are your desired outcomes for controlling these things within your schools and your buildings? This is a sort of a summary of why we do use room air purifiers to clean the air immediately in the space. So sometimes we have concerns in a particular space, maybe the cafeteria where students are gathering and there's, they're crowding together and they're very loud and some of them maybe even singing at times. It's immediately in that space where you can put an air purifier that even if your HVAC system is doing a decent job, it can still do more within that space with an air purifier. You're increasing your air circulation. You're substituting for outdoor air requirements. And that's straight from ASHRAE. ASHRAE has calculations that say, here's what you can do by adding air purifiers when you're not getting enough outdoor air in your building. And don't forget, we're targeting to get enough outdoor air because that's what indoor air quality is all about at the top level. And it can create beneficial airflow patterns. And we'll talk some more about that later. One of the things we know is that authorities agree on the benefits. So why are we using them? Because the authorities say it's a good practice to use these when you need to, when you need to supplement. And so add portable air purifiers with HEPA filters is the primary guidance. The reason they call HEPA out is because HEPA specifically is a proven technology that's sanctioned by these bodies, and it's known to work. Does it work? Show me. How does it work? So let's, I think all of you have seen basically all kinds of different types of air purifiers. They come in all shapes and sizes. You know, some of them blow a lot of air, some of them little. And some of them are wall mounted, some of them are floor mounted, some of them are commercial, some of them are residential. Some of them can be in your ducting, and you can even have them in your ceilings. And I like to focus that when you put them in your ceilings, it's a different airflow pattern, and you can really provide a lot of benefit when you suspend them from ceilings or incorporate them into your ceiling panels. So that's something we're not going to go into great detail today, but you can contact me and we can talk about that at your leisure with any questions you might have on ceiling ones. So different types, designs, and applications. Obviously, there's home or industrial, large versus small. Primarily, these units provide a recirculation effect in your space, but there are some that you can actually duct in and out of your space. Some of them come with different sensors, so you can, in addition to, or instead of having separate sensors to monitor your conditions, these will come with some rudimentary sensors to monitor, your particulates, whether you have your concentration of particulates in the air, whether they're safe or you got to start worrying about them, and your VOC levels, so your volatile organic compound levels, which also are part of your indoor air quality. So those are options in many different types of purifiers as well. But fundamentally, what you care about is what they're doing, right? How do they work? And they operate through primarily multiple stages of filtration. So it's pretty typical to see 3 or 4 stages of filtration. And you have air coming into the unit in some location. Usually it's close to the floor, around all sides, perhaps, or on one side. And then you want it exhausting upwards. So this particular vent on the side actually exhausts pretty much straight up because of the way it's baffled. You want them exhausting upwards. And that's probably the best configuration for a typical air purifier. So the air will pass through that pre-filter. It may pass through a gas phase filter, a carbon filter that takes out odors and other things, or a chemical filter that could kill viruses. And then it finally goes through a HEPA filter. And that's where it's really doing the job of capturing those small, tiniest particles like the COVID particle. And then you can get our auxiliary technologies, and we'll talk about some of those as well. But primarily, the number one piece in almost every air purifier out there, or certainly 90-some% of them for sure, is HEPA purifiers. And the reason is because it works. So that's the most common component of an air purifier. And the questions you want to ask around those are, how efficient is it? Well, if it's true HEPA, it's 99.95+% efficient on a first pass. What is the size and thickness of it? How long is it going to last? A residential one is going to be pretty thin. A commercial one's probably going to be pretty thick. How long is it going to last? The quality of the filter system and seals. The seals are super important. You can have a system with the best filter in the world, but if the seal is not tight, it's not going to act like it's supposed to. It's not going to do a job of filtering out what it's supposed to filter out. So there's a myth out there that HEPAs don't work on super small particles. And I think it comes around the idea that HEPAs are holes of a certain size, and if it can get through that hole, but that's not how HEPAs work. They work on different principles, which we can go into another day. But fundamentally, this graph shows you how HEPAs work. They can capture really tiny particles, even smaller than COVID, as well as particles bigger than COVID. And when we talk about COVID aerosols, they're typically in that 1 to 10 micron range. Super small, completely invisible. But the reason they're 1 to 10 microns is because they're in the exhaust of your breath, which has water vapor. So they're captured in that water vapor. That's why they're as big as 1 to 10 microns. But smaller stuff than even the bare particle, these filters can capture. That's why HEPAs are used. As a second stage, you may have chemical or gas phase, as I mentioned. The difference is between carbon and chemical. So carbon captures odors, no problem. Chemical can capture odors the same way, but also kill viruses and microbes. So oftentimes you might want a chemical media ahead of your HEPA filter. So you're killing viruses before they even reach the HEPA filter. It's just an auxiliary system you can have in your air purifier. UV light, I think a lot of people are familiar with UV light in air handling systems where they use them. But UV light is in air purifiers is mostly an auxiliary system. So the HEPA is the primary one. It's capturing 99.97% of what you have. The UV light is sort of like added insurance, added comfort. And same with other technologies. Man, there's a ton of them out there. I haven't listed them all, but bipolar ionization, hydroxyl ions, hyperperoxide ions, photocatalytic oxidation. There are buzzwords galore out there and technologies galore out there. Again, most of them are auxiliary technologies because your HEPA is capturing 99.97% of those viruses. So most of these are auxiliary technologies. With a lot of these technologies, they're all the ones on this page, ASHRAE and CDC are still evaluating them. So BGE doesn't focus on these. We focus on the HEPA filter because that is the primary technology that's doing the bulk of the heavy lifting work. So the most common mechanisms at the end of the day for capturing particulates and COVID viruses and all these things. On the particulate side, it's always the HEPA. On the gas odors and the VOC side, volatile organic compounds that come out of paint and walls and floor, carpet and stuff, it's carbon or chemical media. And for live viruses and microbes and molds, and again, the HEPA is capturing it, but chemical media can actually kill it. And there are auxiliary systems as well that can kill these things that we've talked about. So those are the common ones. I just want to circle back to that. So how does an air purifier work? Well, it works by dilution. What I mean by that is air passes through the air purifier and it goes circulated clean air back in. So if you put your head right at the outlet of the air purifier, you're cleaning in the cleanest air in that room, period. But it's only taking some of it out and spitting some clean air back out, where it mixes with the other air that's in the room, goes back into the purifier. So it operates by dilution. That's how it works. When and where are we going to use these things? How do we apply them? So fundamentally, it's back to contaminants. We apply them where contaminants are unacceptably high. And the way we know they're unacceptably high is we can measure them, or we can assess the system. And again, part of that assessment is determining how much air is flowing through that space. How many air changes am I getting? So measurement, assessment, or even occupant perception. So ASHRAE, as part of their guidelines, say that if 80% or more of people who exposed do not express dissatisfaction, then you have good indoor air quality. But if 80% or more do express dissatisfaction, then you don't, and you should be doing something about it. So there is a subjective component to air quality as well as a measured component. When and where do we use these? Fundamentally, where multiple people are gathering in poorly ventilated space or inadequately ventilated spaces for long periods of time. So again, you have 30 students in a classroom. That classroom has some ventilation. It's got some air changes and some air flowing through it. But is it enough? And if it's not enough, then we consider using an air purifier. As 30 students sit in a classroom for an hour, that buildup of their exhausted, exhaled air, that buildup of sick air, if a kid is sick, starts to accumulate in the room. And you need the airflow to move that out, and an air purifier can help clean that. So fundamentally, we're using them as supplementary to HVAC systems. That's really the bottom line. If you remember our upside down triangle, we're trying to get the ventilation first, we're trying to get the filtration second, and the third thing, if we haven't got enough airflow, we're still not meeting our air quality, let's get an air purifier in there. So how do we apply them? And this part gets overlooked almost every single time. You buy these and you put them in a corner and you turn them on, and then they're too loud, so you turn them half on. You lower the speed a little. But this part gets really overlooked. Airflow patterns do matter. So let's start by looking at your existing system. You've got an HVAC system and it's doing something. It's blowing air in and out of that room. It's doing something. What patterns is it developing initially? It could, depending on where your intakes and exhausts are in that room, you're getting a certain airflow pattern. So you have to look at the location of your diffusers, your vents, your doors and openings. Are the doors left open all the time? Are they open some of the time? All of that matters to your airflow patterns. And it's really important to take stock of this before you simply apply an air purifier and assume it's going to help, because it may not, depending on how you've applied it. There are different ways to kind of figure out, okay, how do I figure out how this air is actually going to flow in my room or is flowing currently in my room? If you're experienced enough and you understand these patterns well enough, you can visualize it. That's a starting point. If you've got an engineering firm working for you, you can model it. Or you can measure it in some cases. You can actually use smoke or other things to measure it. Of course, you have to set up the test very carefully, but it is possible. So just so you know, always we're aiming for good airflow patterns. It is possible to have a bad airflow pattern. If you're standing in a line at the motor vehicles department, and there's a purifier at the front of the line, but the first 3 people are sick and you're the 4th one back, and the air happens to blow sideways instead of up, and they placed it in the wrong spot right at the front of the line. Now that air is blowing past the contaminated people towards you. So locating the air purifier and thinking about the airflow patterns and assessing them is really critical to applying these to get your desired outcomes, to make it work the way you expect it to work. So let's talk about some of the key specifications that are super important when you're looking at an air purifier. What should I buy? So noise is important, CFM is important, which is the airflow, clean air delivery rate, and air changes per hour. And with CFM, by the way, with the volume of air that you're moving, it's always a trade-off, right? If I'm going to get a bigger machine, it's going to be noisier, it's going to take up more energy. So that trade-off is a balance. Noise levels. A lot of people misunderstand noise levels. You know, they're measured in decibels typically. And people say, oh, this air purifier is 55 decibels. This one's 50 decibels. Oh, that's not a big difference. Let's just toss a coin and pick one or the other. 10 decibels is 10 times the intensity, or 2 times the perceived loudness. So decibels, a small change in decibels makes a big difference. CFM ratings of these purifiers, fundamentally, that's the first thing you kind of look at when you look at air purifiers. How much air does this fan move? 400 CFM, 300 cubic feet per minute. How much air does it move through my space? And note that my space that I'm moving through, and the measure of CFM, it's volume. It's volume. So we're always talking about volume. So if you've got 10-foot ceilings in a room, it's a smaller volume than if you have 20-foot ceilings. We're always talking about volume. And when you look at the specifications on an air purifier, you sometimes see 400 CFM. And you say, well, is that the fan rating with no filters in it? Because the fan has a rating. And with no filters and no resistance anywhere, it moves 400 CFM, let's say. But when you put filters in, that same unit might only now move 250 CFM. So what are you actually reading when an air purifier manufacturer publishes the spec that says 400 CFM? You should know whether it's the fan rating or the actual CFM through the unit. Or maybe it's the CADR. The clean air delivery rate is very similar to CFM, actual CFM. It's just a measure that this association of home appliance manufacturers, they've created this test case where they measure the purifier airflow and they measure it for its ability to remove dust, let's say, but a particular profile of that dust, or pollen or smoke. So the CADR is always going to be less than the actual CFM that the unit produces. So an example of this is if the fan CFM max setting is 400 CFM, maybe the airflow actual CFM is 250, and then the clean air delivery rate, CADR, for dust is 200. So you can see that what you care about is probably the CADR more than anything. The actual is super important. What you care least about is what the fan rating is. So don't undersize the unit by using the wrong specification. And I mentioned that CFM is always a trade-off with noise levels and power draws. And power draws are these things, some people think, oh, I'm going to need to change my panels and do a bunch of electrical and add stuff. These units most often plug into your wall outlet with no changes to your existing electrical, no changes to your existing panels. They don't draw a lot of power or as much power as people tend to think. And again, it depends on the size. Number of air changes per hour. This is a critical concept that we keep talking about, so I wanted to illustrate it. You have a space, you have a volume. In this place, you look at your cube, it's a room. And the number of times that room has a volume of air, the number of times you clean that volume of air in 1 hour is what an air changes per hour is. So if you clean that volume of air once in an hour, then you get 1 air change in that space. If you clean it 3 times, you get 3 air changes. So with an air purifier, it's super important to focus on the air changes per hour when you are assessing what you actually need. What CFM of air purifier will deliver the air changes per hour that I need? Well, how many square feet does it purify? That's the wrong question, because when you look at square feet of a space, that means nothing. Like how many air changes do I need in that space? Again, if I have 10-foot ceilings versus 8-foot ceilings, it's a different volume of air. So 1,000 square feet is a meaningless spec unless you also tell you that's based on this ceiling height and this many air changes per hour. Does that make sense? I hope it does. And that pretty much wraps up my portion of the walk through this forest of information, and I'll turn it over to Randy.
Thank you, Patrick.
Hey, before we switch over to Randy, just one question I hear quite often on that, Patrick. Why like a fan rating on your example of 400? Why does it drop so drastically down? Like I think that 400, that's basically the fan, but with no filters inside the unit, right? Is that big drop there? Yeah. Exactly,
and you got it. So the fan setting at 400 is just the bare. You take the fan out and you put it on a desk and you test it, and it can pass 400 through. Now you put it in the unit and you add a HEPA filter. A HEPA filter, the reason it works so well is because it stops things. So it adds a lot of resistance into the airflow. So it actually, every time you add a HEPA filter to a fan, you're going to lower that airflow.
Yeah. Yeah, I've always thought that's a silly spec to even publish. Like, who would ever run that thing without filters inside it, right?
Yeah, it is.
CFS. All right, sorry about that, guys. All right, Randy, your turn. Thank you.
All right, thank you. So now we're going to talk about sizing and selecting purifiers and how you do that. So we've talked about ventilation, and you've all seen this triangle 100 times. So we need to calculate how many air changes your system's getting so that we can get to the ideal 6. So there's a couple methods here that we'll talk about, the simple method and an advanced method. So I'll get into that. So the simple method, they call it. It's not highly scientific, but it's a good place to start. The inventory air handling units and the CFM and the volume of air they're creating with the MERV rating. And then you look at the spaces it supplies and figure out the volume of those spaces. And then you can do the math. And in this case, you would assume that the rooms are equally balanced. In real life, they probably aren't, but just for this case, you would do that. And it's not scientific per se, but it's a good starting place, and it should give you a good idea of where you're at. There's a couple other methods, advanced methods. You can install a CO2 sensor, which will tell you when the room's not occupied and when it is occupied. And with the volume, there's some calculations you can do to estimate the air changes per hour you're getting. So that's another way. And if you want more information on that, you can go to the website at the bottom there and you can see the calculation. Or you can measure it. So you can use a bolometer, anemometer, go into the room, actually measure the air coming in, the air going out. And it's probably the best way and most accurate to get this level. But it's going to take a lot of time. To do every classroom and every school, it would take a lot of time. So once you have those levels, you're looking at your classrooms. In this example, we have some have 3 air changes per hour, some have 4, some have 5. You're not going to deploy one of these to every classroom and every school all at once. You wouldn't. I'm not sure any supplier could do that, and I'm not sure you'd have enough people to do that. So you would start with the red ones, the ones that need more air changes per hour than the others. So, and start there and then move on as you can. So we've got the air changes per hour. We figured it out from one of the methods I talked about. How big a unit do we need, or how many do we need? So for the example we have, we're going to start with the ones that were red, the 3s. So we have 3 air changes there. So we need an additional 3 air changes from the CADR from the units. So here's a quick example, just to show how you would go about that. So you have a 1,000 square foot room with 9-foot ceilings. So that would be 9,000 cubic feet of air in that space. So you take the 9,000 cubic feet. You're looking for 3 air changes from the room air cleaner, which is 27,000 cubic feet divided by 60 minutes. So you're looking for 400 CFM to get those 3, an extra 450 CFM to get those 3 air changes. So now we know what we need, we know what we're getting. Now, how do we pick one? Well, in this example, we're looking for 400 CFM. There's a few things you could do here. You could go right to the big one and you would be at the right amount for the CADR. Now, in this example, we've adjusted for noise levels. In a classroom, if it's quiet and you're trying to teach, you're probably not going to run these on the highest level just due to sound. So we've adjusted this down to the medium level. You could run them, if you can run them at high, you could use less, but realistically, you're going to use the second level. So you can get the big one, which will run at about 460 on medium. You could get 2 of the middle ones. You could get a small one and a middle one, which would get you close to your 450, or you get 4 small ones. And a lot of this would depend on, like Patrick was talking about, airflow patterns. And, sometimes it's better having them in a couple of places in the room than just one big one in the corner. So that's very specific to your needs, and that's how we would help you decide it. But this will help you decide which size you need and what you actually need, rather than just buying a unit from Costco and throwing it in a room and thinking it's helping anything. So if you need help with any of this, we can absolutely help you figure that out. And you have to also remember, this is pieces of equipment. You can't just drop it in a classroom and expect it to work for years and years without looking at it. It needs to be maintained, and if you maintain it, it will last you. So you should inspect it, have a look at the pre-filters, the HEPA filters, the media, the pre-filters. If you look after the pre-filters, the HEPA filters should last you for years. Some of the units have all-in-one cartridge, where when you change the cartridge, you change everything. Some have different layers, so you can change the pre-filter separately and the carbon or the gas phase media separately and the HEPA separately. It really depends on the system you have, but you should be prepared that this is going to have some maintenance costs and maintenance along with it. You can't just put it in the room and never look at it again. So that's my quick part. I am going back to Ian, and thank you for listening.
Right on. Thanks, Randy. Okay, well, I will take us home here in the last 10 minutes and hopefully leave a full 10 or maybe 8 minutes for Q&A, and we can go past noon for sure. So just a couple other considerations. I got to take control here. We'll talk about just a couple other considerations, and then how we can go about doing this. So purchase considerations, a lot of this is more like a checklist. A lot of these principles were covered by Randy and Patrick, but obviously we spent a lot of time just this last section with Randy on sizing, and really thinking through doing your assessments. There's new, we know all of you've got new schools in your divisions that probably have been engineered to a higher standard, have got new HVAC systems. So there may be rooms in those facilities you don't need these things. So we always caution customers that, don't deploy this technology where you don't need it. I know there's certainly in schools, there's probably political type concerns, and, one teacher has one in her room and the other doesn't have it. And, there's complaints can go around, or parents saying, well, how come my kid's classroom doesn't have one and the class down the hall does? So certainly that can be a challenging thing. But I think if you get out in front of that, do the work to perform the assessments, keep people posted on what you're doing, and educate them as well that, if we've got a room, the HVAC system is delivering 6, 7, 8 air changes per hour, that, that's actually likely a much better solution than a better situation than putting the room air purifiers in there. So yeah, noise, the sizing, all that, we've got to make sure we're doing those assessments properly. But obviously the filtration layers, so all those different layers that Patrick talked about, the pre-filters, the gas phase, antimicrobial, that's all about what do we want to capture. And it's important to think about, there's COVID now, and we want to capture viruses, but we talked a lot about how these are really beneficial for indoor air quality. We've got tons of forest fires going on every year in Western Canada. So these are fantastic units during forest fire season to take out smoke, and there's certain units that are more effective at that than others. So just be thinking about what you want to use them for, and choosing the right technology inside of them. One we didn't really cover, durability is a really important thing, I think, in classrooms in particular. I'd say it's kid proof. I remember, my kids are older now, but I remember when they were in grade 2, 3, 4, you got 30 kids running around there. So there's a couple things. I mean, commercial grade ones, they are made of metal, not plastic. The plastic ones, you boot one of those once and it's going to crack, and then all of a sudden, your air is not going through your filters. So just sturdy units are smart. There's lots of these tower type ones. If you've ever seen them, they're really small footprint, and they're very easy to knock over. So just think about the durability as well on that thing. Just some other considerations. We've talked a little bit about this as an assessment tool, but indoor air quality monitoring, this is a big, often purifiers go hand in hand because of all this assessment. And we want to, figure out what contaminants are taken out of the air. We want to measure that. So it's a great, these monitoring things, the cost of them has come down significantly. They're great tools. They're great for doing your ventilation assessment. Randy talked about using it to figure out your air changes per hour that you're getting, but they're great as well deploying them long term, and they can help you. They monitor your air 24/7. We call it making the invisible visible. So you can have eyes on your air quality, and you can identify issues and go to work on them and remediate and all that. And and you can see the efficacy as well of things like your air purifiers. So great technology to keep an eye on. I will mention, these are probably good things to start looking at anyways, even if I know you're focused on MERV 13 and purifiers and everything, but I just pulled a couple of quick things that I've seen recently. So we've got parents sneaking monitors into their kids' school. I don't know if any of you have seen that yet, but there are kids now coming to school with little, you can buy these things, little home ones for $100, and so this technology is coming. It's quickly becoming very ubiquitous. Lots of people have these in their homes now, and recently, institutional wise, we just saw a little while ago, Quebec, actually, the province of Quebec announced they're buying 90,000 and putting one in every single classroom. So this technology is coming, and something to think about. They go nicely hand in hand with this purification. We'll talk approach. We've covered lots of material. It's obviously a lot to take in, but we have a suggested way you can go about calling this your purification program. The assessment. I'm not going to harp on this one again. We've talked about the critical importance of assessment. It really is the foundation for everything you're going to do forward. So understanding your spaces, understanding your current ventilation, and then building your plan from there, because everything you do in your assessment is going to identify all the things that you're going to want to do. It'll allow you to prioritize your high risk areas that you're going to focus on first. So the importance of putting that plan together, and then communicate that plan. We're seeing great examples. Many of you on this call, we're seeing excellent examples of just getting out the communication through parent newsletter. My wife and I have received one of them. And talking about what you're doing to improve ventilation and air quality, because it's on everybody's mind. And I'm a firm believer that, I'll speak as a parent. I don't expect the schools to be able to do everything tomorrow, but it's nice to see that, okay, we're thinking about it, we're taking some early steps, and that we're going to be working on it. So I think that's really important. You got that's because all of this is going to take you time, and you have to buy the time. And I think buying the time is communicating and being transparent about what you do. Obviously deliver. So you've got your plan, start chipping away at that stuff. Communicate as you go. People like to see progress. They'll cut you more slack. They see you making progress. And then manage. So Randy talked about that. Make sure that we don't just rush, put all this stuff in, and then not have a plan to keep this all up. So make sure you're managing that. So this will be my one shameless plug today. We can help with a lot of this. It could be any one of these or all of the above. We can help you with the assessments. We can help you draft, review your plans based on the findings of that assessment. Source your units. We are vendor independent. I mean, we have some brands and units that we like, that we've evaluated dozens and dozens of them. But this is going to be a challenge if some of the school boards start going here. The supply chain issues are not insignificant. You likely, especially for the bigger boards, you likely will not be able to have one vendor, one unit. You may have to source for many. So just managing that, we're happy to help anybody with that, or even referring different brands and things. Setup, placement, commissioning, waste disposal. These aren't terribly difficult to deploy, but there is a bit of work involved. I call this fleet management. Think of it as a fleet. It's a fleet of equipment. So, and you can optimize that fleet over time. You may deploy some in areas and realize, we've got really good ventilation there, but we could move those to an area we don't have good ventilation, so they can be moved around and based on some testing and things. And then obviously we have maintenance teams that can help with the replacement, inspection, repairs, warranty, all that. And then any monitoring requirements that go along with this. We also have, we can wrap this all up if budgets are issues and it's easier to pay for things over time. We've got flexible plans and we've got leasing options, different things we can talk about. So, okay, this is our bridge into the Q&A. We've seen a lot of questions out there already, whether it be on social media or customers calling us. So I'm going to throw a few of those things out here. We're seeing a lot of misunderstanding about some of this. So we've set all these principles, but I'm going to just give you some examples of some of the things we're seeing, just to kind of prime the pump for our Q&A discussion here. Maybe I'll answer some of the questions already with this. So one of the things we're seeing, or hearing from customers or seeing on some school websites, ASHRAE recommends air purifiers only when no mechanical ventilation exists. Or ASHRAE recommends HEPA units only when HVAC filtration can't be upgraded to MERV 13. And so, the ASHRAE guidance is quite clear. Statements like that are not consistent with the guidance. I would ask for that first one. So let's say ASHRAE recommends only when no mechanical ventilation exists. So you have mechanical ventilation, but what if that mechanical system is only delivering 1 or 2 air changes per hour? It's definitely problematic. Or ASHRAE recommends HEPAs only if we can't upgrade to MERV 13. Well, again, so what if we've upgraded to MERV 13, but there's only 1 air change per hour passing through that MERV 13? So we should just be careful. I actually really feel for you guys trying to communicate these things out, because the guidance has not been clear. ASHRAE themselves have admitted this, the way they word things. So just be very careful, and we're happy to review your communications or statements like this, because we don't want you to get in trouble or get called out for statements like this that are not consistent with the guidance. So again, just the guidance is, and ASHRAE is the same, it's 6 air changes per hour. I went through this in the last webinar. There's even a letter right from the chair of the epidemic task force written to Alberta schools clarifying the guidance. So I'd encourage you to look at that letter. Many of you have probably seen it already. Clears some of this confusion up. Heard this from a customer a short while ago. I've heard purifiers draw 4 to 5 amps each, and 30 in a school would add 150 amps to our panel and overload our panel. So they're quite low power draw, these things. They're just running a simple fan inside of them and maybe a little bit of electronic controls. So smaller units, the ones, we showed a couple examples, they're only drawing about 0.5 to 1 amp. The medium units, maybe 1.5 to 2. So, on the high end, if you had 30 of these, the medium units, you're 60 amps, and on the low end, 30 or less. So that's equivalent of, say, 1 to 2 home air conditioning units. It shouldn't be a huge issue, but certainly if you're concerned about electrical draws, obviously consult an electrician. I heard standalone units can blow infectious particles towards other students. Very simple. Patch talked about this, really critical requirement, and make sure you check when you're buying these things. They should blow the air up. In creating those beneficial airflow patterns. Our HVAC systems meet ASHRAE standards. We see a lot of this statements like this. So which standards? So do they meet 62.1, which were a couple of years ago, or do they meet ASHRAE Epidemic Task Force guidelines? Because the Epidemic Task Force guidelines, the key changes are, MERV 8, no, MERV 13. 2.8 air changes per hour is roughly in the regular standards, and we're supposed to be shooting for 6. So, just be careful about that as well, because the Epidemic Task Force guidelines, effectively are the ones we're supposed to be shooting for right now. Some of you will recognize this. I'm not going to say, but this was an example. Jerry, HVAC engineer, his wife's preschool teacher. He was given 3 minutes to speak to one of the school boards. I know we've got that school board on here today. You'll recognize Jerry, I'm sure, but this is the reality we live in, right? We've got access to this information. We've got parents who are engineers. So again, I feel for you folks, and so we're going to have parents like this, going to your boards and saying, "Hey, the statements you publish over there were wrong," and I'm an engineer and I know this stuff. So, I I do feel for you guys, but we've got to be on top of this stuff because it's very easy to get this. Heard this one a little bit. COVID is almost over, so why are we going to do all this for the next couple of months? Well, there's really, I'm not going to project this, but we're reading the tea leaves here. There seems to be, there will be updates to the regular ASHRAE guidelines in the next couple of years. We're seeing some pretty good indications that, they may not go all the way, but a lot of these Epidemic Task Force recommendations will likely make their way into the regular standards. There's a good podcast from the chair of the Epidemic Task Force talking about this and where he thinks this will go, if you're interested. We're getting short on time here, so I'm going to, I've got some questions coming in, so that's great. But on this, COVID is almost over. Why do this for just the next couple of months? So let's think about cold and flu seasons going forward. We're about to, they're saying we're about to enter this endemic stage, and this will become an annual, sort of COVID season. So these are great. All of these strategies we talked about are certainly really beneficial going forward, way beyond COVID, right? And just remember, again, I'll bring Jerry back here, parents, teachers, all your stakeholders. They're highly educated about this, the importance of good indoor air quality even beyond COVID. So, I guess my questions are we ever going to, as a public, are we ever going to accept going back to 1 to 2 air changes per hour? Are we going to accept going back to MERV 8? I highly doubt it. So don't think you're throwing this money away and it's not for the long haul. So I'll leave you with 2 final thoughts and then we'll take a bunch of questions. So this one, the world has really changed and people are now entering any indoor space, a home, an office. We're seeing tons of this with our commercial clients. Their tenants are asking when they're coming back, they're asking 2 questions. What am I breathing? And how do I know? And to drive this home, we're seeing tons of building standards pop up. This is the well building standard that, a lot of big Class A commercial buildings are certifying their clean, healthy buildings to. And I threw this picture up there because this, some of you may have seen this commercial on TV, but when J-Lo and Lady Gaga are getting on TV talking about healthy buildings, this is this is made it, and this is not going away. So how long, before folks enter your schools and ask this? And I suspect, going back to Jerry, they probably already are asking these questions. Last one, I brought this in the last one, but I think it's a great thought to leave behind for all the important work that you folks are doing. But there's a great quote from the Healthy Buildings book: the person who manages your building has a bigger impact on your health than your doctor. We believe in that, and you have really important work to do. So let's get to doing that work, and because clean air really, really matters now. So thank you very much for the thing. We see some questions coming in here, so we are here to help, and we'll start with some questions. So Randy and Patrick, if I can get your cameras back on, guys, we'll start to go through. So Corey, so he's probably referencing a specific slide. I'm not sure which one, but it's to be used as a supplement if needed. It's for more pathogens and overall improvements for flu diseases. Patrick, do you know which slide that might be?
Yeah, I think he was just talking sort of the long-term use of the air purifiers, even as we get past this current COVID wave. Yeah, we're always going to have pathogens and the flu season and the cold season. So these always will be a valuable supplement going forward. So yes, Corey, to your point. Thanks.
Right on. And folks, I'm just noticing the time. I'll just give you a reminder in case you have somewhere to be. It's about 2 minutes to 12. So if you do need to jump off anytime in the next 1 to 2 minutes, don't worry. We'll keep going answering questions, but all these will be recorded so you can see the rest of the Q&A. Okay. So we'll go to second question from Amanda. Regarding blowing infectious particles into students' faces, is there a difference between air coming out of purifiers versus normal fans because the air purifiers blow clean air?
Yeah, Patrick, so I can take that, sure. Yeah, obviously, like I mentioned, if you put your face right up to the air purifier exhaust, it's the cleanest air in the room every time. So it is clean air. So anybody sitting next and around that air purifier is going to be breathing in the cleanest air. And as that air purifier continues operating, you got 30 kids in the classroom, they're breathing out all the time. It's always capturing what they're breathing out. So if you just had fans in the room moving air around, that would do nothing other than move the COVID particles around in the room and increase the risk. With the purifier, exactly, you're right, that's what it's doing. It's capturing those COVID particles, putting clean air out, and diluting the COVID-y air with clean air that everyone can breathe in. Yeah, the concern with the airflow patterns was if you put it at the back of the class, let's say, and the kid at the back of the class is sick, and the air was blowing, let's say, sideways across the face kind of level of people, then you could blow air past that sick person and it would continue blowing to everybody else. That was the concern. So you don't want to blow at the face level. You don't want an air purifier that blows out sideways. That's why Ian talked about making sure it blows upwards, but also locating it in the proper place. Ideally in the middle of the classroom. If you're doing one, if you're doing two, you can create some better airflow patterns, but there's all kinds of things you can do to make the system optimal so that the risk is less and your air is clean for everybody.
Thank you, Patrick. The next one, good question here. We'll go to Patrick again. What is a good noise level to look for classroom? And Patrick, I'll bring our noise. We got to specs on a couple of these.
Yeah, and that's a great question. The reality of it is sometimes the actual specs are a little off. So if somebody says it's 50 decibels, it could be 52 or it could be 48, depending on how they're measuring it. So the reality, and it's a big difference. Like I say, when we look at decibels, 10 decibels is 10 times the intensity, a difference of 10 decibels, 2 times the loudness that you perceive. So a small difference in decibels does make a big difference. You should really be looking when you run these machines in your classroom. If you've got a boisterous classroom, you can run them slightly above 50 decibels. If you've got a completely quiet classroom where the goal is to hear the teacher whisper, you'll need to run them below 50 decibels.
Yeah, I'll just add to that. We're just in the field. I mean, we've tested a ton of these things. We have yet, we think we might have one soon that we'll see in a couple of weeks, but we have yet to see one that we can run on high fan speed. So if you look at these, like Patrick said, if you look at these units, it kind of that threshold is of 50. Like these ones go you know, these two, small and medium, they start, their mid fan speed is 50 and their high fan speed is 56, 55. And I'll tell you, you think only 5 dBs, but man, you go to 3 and it is noisy. We can't do it in boardrooms, we can't do it in classrooms. It's pretty tough. So
something like a cafeteria where noise isn't that much of an issue, you could run them on high.
Yeah,
good
no
point.
question.
Okay, next, great questions, thank you. Good noise ever. Kevin, so Patrick, what specific chemical were you referencing for killing COVID? Yeah, that's a good one, because chemical media, we know what that means, but we should explain really what it,
Yeah, so the chemical name I'm mostly talking about, and there's different ones to be honest with you, but the one I'm mostly talking about is potassium permanganate, and it comes in different concentration levels. So how efficient it is at killing things depends on how concentrated it is. But it's a very common safe chemical that's out there. We have it it's shown in these air purifiers where you see the purpley pink stuff. That's what it is. It's that potassium permanganate that's sitting in those cartridges that are killing the virus and also killing odors as well. So it's a dual purpose.
Yeah, maybe just talk, there's a lot of terms out there, like chemical media, gas phase media. I think there's a few different sort of terms, but it's more reference to.
Yeah, so carbon and what I call engineered chemical media. Yeah. Carbon and engineered chemical media both do kind of the same thing, have the same platform. So what they do is they capture odors and gases, volatile organic compounds. That's what they do. They don't capture COVID particles. They don't capture them. They don't capture anything other than gases. But they kill. A carbon doesn't kill anything. It just captures. So a carbon's very similar to a HEPA filter in that whatever gases you capture, they just get sucked in there and stay in there. But an engineered chemical media is designed to do more than that. So what it is it's typically the same base as carbon, but they impregnate it with a different chemical that does more. So kills odors even better, or more different odors or certain odors, and kills viruses.
James has a question: to overcome the physical space and noise concerns, what about placing the purifier in another room and ducting it into the space? Good question.
Yeah, so where you can do that, and not all air purifiers have that ducting, that is a good option to do that if you're still trying to create those airflow patterns. The only concern I have with it, if you like, is you can really only reach one spot in that room, and it's typically the wall, right? And that's not necessarily the best place for creating a good airflow pattern. So you still want to think of the airflow pattern piece of it as well, if you're going to go that route of ducting. But the other thing to do to consider would be like a sealing module. You can duct a sealing module, or you can just suspend it, and it can create. There's ways to set it up to create the absolute best, healthiest airflow patterns for you, and those units are fairly quiet as well. So that is another option to look at.
Which I think,
but yeah, they're great options to look at. The other reason a lot of people like to have it not ducted, so they can just move it around from place to place, right? It's so nice being able to have it mobile, so you can move it to where you need it.
Randy, were you gonna add something there?
I was just gonna say his ceiling module idea is basically the same principle James is talking about. It's just in the ceiling instead of another room.
Yeah, although it doesn't necessarily have to be ducted. But so you can suspend it from the ceiling. You don't have to duct it. You can insert it where the ceiling panel is. So it doesn't have to be ducted, but you still have to supply electrical to it. So there's that added piece.
Yeah. I'll take this one from Brian. I'll give Patrick a chance to drink of water there. Does a purifier need UVC inside if it has a true HEPA? So that's a great question. We were just talking about that last day or two here. So we're big fans of UVC, and UVC is well recommended and, by ASHRAE and many others. Our position on that generally is we view it, if you have a good unit, it's well sealed, and you've got a high grade HEPA in it. You're right, Brian, that like I think what you're hinting at is that HEPA should capture everything. There's not much getting by it, so why do you add UV? So that generally that is our position. We like that technology. We like it in, for upper room applications or inside ducts and things like that. But generally, our position is that it's a peace of mind thing. Maybe it's one more extra layer, but it is a little bit redundant, and it's something. It adds cost. Your upfront cost. You got to now replace those bulbs. It's something else that can break. So, not bad technology, but we feel if you do have a good HEPA unit, it's a little bit redundant. Anything to add, guys, or did I?
Well, yeah. Again, the UV is only as good as how long it's able to shine the light on the particles that are passing past it. So if you've got a fast airflow in a small space, which is what you really have in an air purifier, it's limited in what it can do. Mm-hmm. And the HEPA is doing 99.97% anyway. So is it adding value?
It's really good technology inside of HVAC units to prevent mold and build up, because you can shine the light constantly on the surfaces in there, and it'll constantly be killing stuff. So, but let's move on from UV. Corey, any recommendations for HEPA HRVs to look at? Mr. Equipment Engineer.
Yeah, and I don't know, maybe Randy wants to pipe in here as well. No is the bottom line. I don't have any recommendations for HRVs. Heat recovery ventilation units. I don't have any recommendations for those. They often don't have HEPAs in them. And a HEPA is just an added track where you put in a HEPA filter anyway. So you can put, it's more important is what is the sealing of that track? Is it a good sealing track for the HEPA? But I don't have any specific recommendation is the bottom line. But a good question. And HRVs are great. So keep using them.
Yeah, they're great. I'm actually going to get one in my house.
We don't have recommendations on a specific brand, but if you have one, we could certainly give our opinion on it.
Yeah.
Chris, some manufacturers are stating that effective purification is to remove 99.97%. Curious if there are specification or requirement around this, or it's just a sales pitch for their equipment. Good question. I guess you covered that. I get pretty well, Patrick. Do you want to take that one?
Yeah. So if it's a true HEPA and it's a good sealed unit, like a quality built unit, the HEPA itself, the true HEPA, removes 99.97%. It does. It's tested to that. All these HEPA filters are tested that way. It's a little maybe a little less stringent on the residential side stuff, but on the commercial side stuff with a big commercial HEPA, they will remove 99.97%. Now, if you're talking about other technologies, ionization, oxidation, UV, they have certain efficiencies under certain conditions. But you have to look at those closely and say, does this match what I'm applying into my classroom? And do I need it anyway? Because I got a HEPA filter that's doing 99.97%. So a HEPA, you can specify when you do an RTF or whatever, you can say, I want a HEPA filter that is going to remove 99.97% of all particles. And that's what they're spec'd to do. It's not, HEPA is not a sales pitch if it's a quality unit.
Yeah, HEPA has been protecting people for surgery or on the table. HEPA has been protecting in those types of environments for many decades. So it's good technology that works. Do in-room units pose a fire risk? Do we know? Anybody want to take a shot of that?
Well, they're an electrical device, right? So does your toaster pose a fire risk? Does your tea kettle pose a fire risk? It's an electrical device. No more fire risk than anything else, and they're certified. They're UL certified to be safe.
Yeah, you obviously want to check that. Presumably, you'd be getting one that is, but certified. Does UVC inside in-room units increase the power draw?
Everything you add increases the power draw. Yes, definitely.
So again, back to my point around potentially is it redundant if you believe HEPA's doing the job. Another potential.
And I've seen
Awesome.
air purifiers that they have a HEPA filter, so that's capturing 99.97%, but they want to make sure people buy it. So they add a UV, they add ionization, they add photocatalytic. I saw one with 4 auxiliary additions. Those all add to the power, they add to the cost. Better to take your money, I think. I mean, this is one man's opinion, and put it in a good quality unit.
Pauline, sorry, I'm not sure what happened there. I replied, but you asked if this started. Yes, it started quite a while ago, so I'm not sure what happened there, but we'll be sure to get you the recording. Brett, can you talk about the pros and cons of bipolar ionization technology used with HEPA filters in an air purifier?
Yeah, that's a difficult subject, again, because ASHRAE hasn't sanctioned it yet, or CDC. They haven't sanctioned it yet. So, you know, manufacturers have their specs and their claims, and by all means read through them and listen to their sales pitches, and you have to decide for yourself. We as BG are not ready to adopt that technology. We're very big on following ASHRAE standards, and so we're just not ready to adopt it. I think it's going to have a certain efficiency, but I don't. Again, you have to look for yourself and decide whether that's for you. We aren't going there currently as a company, but we follow it. We follow it super closely, and the day it becomes sanctioned by ASHRAE, if it does, we'll be on top of it. So happy to help you offline at any point in time, but we do follow it.
Yeah, and just be clear, ASHRAE, CDC, others, they're not saying one way or the other. They're not saying it's bad. They're not saying they're good. They're just basically saying that we need a little more data. It's a newer technology. We want more research to be done on it, and when the time comes, I suspect that it will. That it will come. I'm going to go to Casey and then the next guest, and I'll loop back with Brody. Brody's on our team, and he's got a question about some schools, but I'll prioritize the customers. Sorry, Brody. Casey is asking, isn't the 99.97 efficiency based at a certain CFM? Good question.
It's typically at or below a certain CFM. So the HEPA filters, the HEPA filters that they put in these units are made to handle the CFM that the units can deliver. So they would be 99.97% efficient at the CFM for those units.
They should be. That's how they
should be. If they're a quality builder and a genuine, honest manufacturer, they should be.
But the actual 99.97 is based on a particle size, not a CFM. It's 99.97 on 0.3 to be a true HEPA. So that's where they get that number from.
Right. Another guest, is there a standard or a way to evaluate the odor removal ability of carbon or charcoal units? Who wants to take that one?
Yeah. So there are different ways to evaluate it. One of them is using VOC monitors. If VOCs are some of the chemicals you're trying to get rid of. So some of the monitors that we showed at the end, or Ian showed at the end, those things are able to monitor your VOC levels, and those give you an indication of how your unit is performing for odor removal. If you have a specific odor from a specific gas, like wastewater treatment, they have specific odors from specific gases, then you would maybe want to monitor that gas separately, a different way. Randy, do you have anything to add to that? I don't know.
Yeah, and it's just it's a little complicated when it's everything, but if it was a specific thing, you can actually go off the spec of the media you're using and calculate how much it would hold and the approximate life of it.
Right.
And actually, we were just talking to a manufacturer of one of those a short while ago, and the units they have, there's an indicator light on the front of them that will go on, when it's time to check the filter or change a filter, and they actually have one for the chemical medium. So I asked them, well, like how are you determining that? And so they said, well, no, it is on a timer, and but that light should be more to go check the filter And so some of the methods the guys are talking about, or, you know, we can sample, you can certainly sample the chemical media in there, send it away and figure out if it's all spent. Okay, we're getting close to the end here. Oh, that same person was thinking forest fire smoke. So how would we figure out if the carbon is spent and we're not protecting against smoke anymore?
The problem with forest fire smoke is it's intermittent and the levels range so much differently on each day. So it's almost at the point where it starts to break through, or you start to smell it, because it could be super bad for 4 days, or it could just be consistent for 2 weeks. So it's hard to determine that way.
Okay, I'm gonna loop back to Brody's question, and then it looks like we're getting close to the end here, guys. And it is 15 minutes after, so I know some of you are dropping off. That's okay. I've had a couple schools mention they would like to have purifiers that are tamper-proof. Is VG able to support with customizing purifiers to avoid some of the younger students wanting to press buttons on the purifiers with a locking mechanism or having the units tamper-proof? Oh, good question. We just talked about that, Randy, the other day. You want to take that one?
Yeah, an electric fence. No, I'm kidding. There are ways we can help you with that, and there are units that have that. But there's, as we talked about, there's different schools and different needs, and we can usually help or accommodate a lot of that. And we've even looked at some ways to perhaps turn them on and off and adjust them automatically, so you don't have to use the buttons at all. So, but these are all options.
Or ceiling buttons.
Yes, plug for the ceilings. Yeah. That's a good point. Hopefully they can't get up there. Okay, well, that's the end of our questions. I think we will wrap there. If there's any others, certainly don't hesitate to reach out and ask us. And like I said earlier, we're here to help. So thank you. Good luck, everyone, on this journey. I know this stuff isn't easy. Again, I feel for everybody. This is not an easy path, but based on all the work we're doing and with many of you, you're taking some great steps. So keep it up and let us know where you need help. Thanks very much for your time today.
Thanks for listening.